Welcome to Tomorrow Unveiled. Today we're diving headfirst into a topic that, well, it's felt like science fiction for ages, but now
hmm
it's undeniably becoming our reality. We're talking about the rise of the machines.
hmm
And honestly, this past week, it really felt like a watershed moment for humanoid robotics.
hmm
Our research team found this convergence of breakthroughs. It's not just small steps, it feels like a massive leap forward.
Exactly. What we've seen just in the last 7 days or so isn't one big announcement.
That's
It's like a synchronized full stack advancement across the board.
Draga.
Yeah, hardware, software, AI, everything moving together. We're seeing robots really shift from just being lab curiosities,
Yeah.
to becoming genuinely commercially viable,
hmm
general purpose machines ready to, well, poised to operate in human environments safely and effectively. It's quite something.
And what makes this deep dive so important for you, our
Mhm.
listener, is we're going to unpack these developments. They're all interconnected.
Yep.
We'll look at the new brains, the minds powering these things, see what they're actually doing in the real world.
Some impressive demos there.
And then the market signals,
Yeah.
the money, the investment, it all hints at something big coming.
hmm
So yeah, get ready. Some of this is pretty surprising.
hmm
Okay, so let's kick off with the hardware, the processing power. What really jumped out from our analysis was this absolute leap in computing capability inside the robots themselves.
Right.
It's like, imagine stuffing a supercomputer, basically, into a mobile robot, not in some server farm miles away.
Yeah, and this is where Nvidia's Jetson Thor really comes into the picture. It's being called the new robot brain, and for good reason.
Okay?
Think server-class computing power, but purpose-built for what they call physical AI, and it's squeezed into a mobile power envelope.
Physical AI, meaning AI that interacts with the real world.
Exactly. Perceives, reasons, acts. And the specs are, well, pretty staggering. Up to 2070 FP4 teraflops of AI compute.
Okay, teraflops,
Yeah.
lots of power. But FP4, that's a specific type of calculation, right? More efficient for AI.
Precisely. It's optimized for the kind of math AI relies on, especially for processing vision and sensor data incredibly quickly. Millisecond decisions.
Yeah.
Like having an AI supercomputer built right in.
Wow. And our research team also flagged the memory, 128 gigs of high bandwidth memory. That sounds important too.
Oh, it's crucial. It's like the data highway for the brain. It lets the processor access and crunch these huge AI models without, getting stuck in traffic. Absolutely vital for real-time intelligence.
But it's not just about raw power, is it? What's the big shift here?
Well, the really transformative part is where the thinking happens. It's moving from the cloud
Right.
down to the edge, directly onto the robot.
Okay, so on-device AI, why is that such a big deal?
Because it means the robot can run these massive generative AI models, LLMs for language, VLMs for vision and language, even VLAs, vision language action models.
DLA. So understanding a command and turning it into movement.
Exactly. Pick up that box into the actual physical actions. Doing that on the robot is critical for dynamic, unpredictable places like, say, a factory floor or even your home.
Because a delay could be disastrous.
Totally. A split-second lag waiting for the cloud could be catastrophic. This edge processing truly lets the robot be an intelligent agent. Perceive, reason, act, all autonomously.
And industry is noticing.
Oh, yeah. Our findings show major players are already on board or evaluating it. Agility Robotics, Boston Dynamics, Figure AI, even startups in China like Unitree and UB Tech. There's real confidence building around this approach.
Okay, so Jetson Thor is the powerful new brain.
Mm.
But what about the mind? The software, the intelligence running on that brain? Our research team highlighted a big breakthrough from Boston Dynamics and Toyota Research Institute. They're calling it a large behavior model, or LBM.
Yeah, the LBM. It's pretty revolutionary. It's a fundamental shift away from how robots have traditionally been controlled.
How so? Less coding.
Way less direct coding for specific tasks. Think about it. Usually, you'd have engineers writing tons of code for every single skill, right? The LBM is different. It's a single large neural network that handles end-to-end control. The whole robot.
End, meaning
It unifies controlling the legs locomotion and controlling the hands manipulation. It treats them as one single problem, not separate modules you have to stitch together.
that sounds much more integrated, like how we move.
Exactly. And the way they train it is really clever. They use teleoperation, basically remote control, but with a VR interface. A human operator essentially demonstrates the task.
So the robot learns by watching a human do it in VR.
Kind of, yeah. It's like
Yeah.
teaching by showing, Not by writing a massive instruction manual for every tiny movement. It learns the behavior.
That feels like a much more intuitive way to teach a machine complex tasks.
It completely redefines what a robot skill is. It's not a block of code anymore. It's a data set derived from these demonstrations.
Wow.
And the kicker. Our research indicates they can add new skills without writing a single new line of code, just by adding new demonstration data.
That must speed things up massively.
Hugely. It accelerates skill acquisition like crazy. This is really the path from single-task robots to truly general-purpose machines.
The guy that could do lots of different things.
Precisely. And it creates this feedback loop, a data flywheel. The more robots are deployed and perform tasks, the more data they generate.
Which makes them smarter.
Which allows them to do more tasks, generate more data. It's a virtuous cycle. Continuous improvement baked in.
Okay, so incredible hardware, revolutionary software. Sounds great on paper. But what does this translate to in the real world? What can these robots actually do now? Our team found some really compelling demonstrations just this past week.
Yeah, the theory is meeting practice now.
One that really stood out was Boston Dynamics Atlas again, but this time in a workshop setting. This was a collaboration with Toyota Research Institute.
Right, not just parkour this time.
Exactly. We've all seen the flips and jumps, which are amazing.
Yeah.
But this was about work, packing things, sorting items.
Purposeful tasks.
Yes. And the key thing wasn't just how smoothly it moved using its whole body.
Right.
It was how it handled, well, being messed with.
The perturbations, yeah.
Right. The researchers would deliberately, close a box lid Atlas was trying to use or slide a box away from it mid-task. And Atlas didn't just stop or fall over. It saw the change, adjusted its plan, and just carried on with the task. It recovered. No human stepping in.
See, that is huge. Moving beyond choreographed routines to actual purposeful work in a messy world. That resilience, that ability to react to the unexpected.
That's the money shot for commercial use, isn't it?
Absolutely. It's arguably the single most important capability needed for real-world deployment. It shows learned reactive behavior, not just pre-programmed steps. Perceive, replan, act on the fly. That's the difference.
But it wasn't all, polished lab demos. There was also a more chaotic event.
Ah, yes, the World Humanoid Robot Games over in China. A fascinating and maybe more unfiltered look at where things stand. 16 countries competing.
So like the Robot Olympics.
Sort of. And there were definite wins. The Unitree's H1 robot, for instance, did really well in track events. Gold medals in the 400-meter, the 1,500-meter.
Wow, running races.
Yeah, showing impressive progress in stable, dynamic walking and running over distance. That's not easy.
But you said chaotic.
Well, alongside the successes, there were the, let's call them learning opportunities.
Oh.
Think brutal knockouts in the robot kickboxing match.
What's your kickboxing? Seriously.
Seriously. And total pileups in the soccer games, just robots falling over each other. It really highlighted the massive difference between navigating autonomously.
It was getting pretty good.
Right, and dynamically interacting with other moving things, especially with physical contact. That's still a huge challenge.
So they can run straight ahead okay, but bump into another robot and it's chaos.
Pretty much, in some cases. But even those failures are incredibly valuable, right? They give researchers tons of data on where the weak points are, what needs improving. It actually underscores why that Atlas demo, handling perturbations, is such a big deal. That's the capability needed to handle this kind of dynamic interaction.
It makes you think. If they struggle with robot soccer, interacting reliably with unpredictable humans is still a way off.
It's definitely a frontier challenge, but beyond the big movements, the sensing is getting better too, right?
Absolutely.
How they touch and feel the world.
Absolutely. You need more than just eyes and brains. Our research team flagged advancements in sensory tech too.
Like the robot's skin.
Exactly. There's this new JIS Protaxoff sensing skin. It's pretty clever. Provides multimodal perception, so multiple types of sensing in one.
How does it work?
It uses a special material that can switch between being transparent and opaque. A camera underneath can literally see through the skin to detect something approaching.
Proximity sensing.
Right. Then, when contact is made, the material turns opaque, and the camera tracks how the skin deforms. This gives it a really nuanced sense of touch, pressure, force, kind of like our fingertips.
That sounds vital for safe interaction, especially around people or handling delicate objects.
Definitely. It's described as a whole new modality in robot touch. And then there's hardware design, improving stamina. We saw the Engine AI T800.
A heavy-duty model.
Yeah, designed for tough jobs. And it uses solid-state batteries.
Ah, Better energy density and safer than traditional lithium-ion.
That's the idea. Longer run times. Plus, they're working on autonomous battery swapping, so the robot could potentially work 24/7, just docking itself for a fresh battery when needed.
Okay, 24/7 operation without human intervention for battery changes. That's another piece of the commercial puzzle falling into place.
It really seems like it. Now, before we get into those huge commercial implications and what's next, a quick word for you, our listeners. If you're finding this insightful, please take a moment to like this video, subscribe to Tomorrow Unveiled, and definitely hit that notification bell so you never miss an update on the future. And if you're listening on a podcast service like Apple Podcasts or Spotify, we'd be incredibly grateful if you could leave us a rating and review for Tomorrow Unveiled. It really does help us reach new listeners.
It does, thank you.
Okay, let's pivot. The big question. When do these machines actually start showing up everywhere? The money seems to be flowing, based on our research.
It certainly is. The financial signals this week were pretty strong. You had Field AI raising a huge $405 million round just for humanoid robotics.
400 million. Wow, who's investing?
Some big names. Bezos Expeditions, Nvidia, Intel. They see the potential. And the market forecasts our team looked at are just eye-popping. Goldman Sachs is projecting a $38 billion market by 2035. Morgan Stanley, they're forecasting a staggering $5 trillion by 2050.
5 trillion. Yeah. That's astronomical. Is that just hype, or is there substance behind it?
Well, it's definitely ambitious. But what's different now, compared to maybe previous waves of excitement, is the ecosystem maturing around it. It's not just speculative bets on cool tech anymore.
What do you mean by ecosystem maturing?
Look at collaborations like the one between Infineon Technologies and Nvidia. Infineon makes chips for motor control, power systems. Nvidia does the AI brains.
Right.
By working together, they're basically creating a standardized, high-performance nervous system for robots. Pre-validated solutions for motor control that work seamlessly with Nvidia's AI platform.
So it makes it easier for companies to actually build the robots. They don't have to reinvent the wheel for basic controls.
Exactly. It de-risks the hardware development massively, lowers the barrier to entry. It's about enabling mass production, moving beyond bespoke research prototypes.
And this is speeding up actual deployment. Yeah. We're moving past the lab stage.
It seems so. Our findings show multiple companies are starting to report actual large-scale contracts, and they're citing real benefits, up to 74% cost reductions in some tasks, 30% operational efficiency gains. These are numbers businesses pay attention to.
And affordability. Are they still incredibly expensive?
The price is coming down. That Unitree R1 robot being announced at under $6,000, that's a signal. Still not cheap for consumers maybe, but for industrial use, that's getting very competitive.
And the biggest potential milestone our team found, Foxconn and Nvidia, possibly deploying humanoids in the Houston Electronics Assembly Plant by early 2026.
Yeah, that report is significant. If that happens, putting humanoid robots on a real complex assembly line like electronics, that would be a massive proof point, moving from warehouses or simple tasks to intricate manufacturing.
But let's stay grounded. It sounds amazing, but there are still hurdles, right? It's not happening overnight.
Oh, absolutely. We need that dose of realism. While the progress on intelligence, hardware, and safety is undeniable, huge challenges remain.
Like what specifically?
Reliable balance, especially on uneven surfaces or when bumped. Getting truly long battery life for a full workday. Handling the nuances of human interactions smoothly and safely. That's incredibly complex.
In regulations.
And the whole regulatory framework around deploying autonomous robots in shared spaces, that's still being figured out. Even Tesla's Optimus, with all the attention it gets.
Still mostly in the lab, right?
Pretty much. It just highlights how incredibly difficult it is to truly replicate human dexterity, balance, and versatility in the real messy world.
So the rise of the machines, it's less like flipping a switch and more like a careful strategic rollout?
I think that's a good way to put it. Well-funded, yes. Yeah. Accelerating, definitely. But still navigating some very real, very complex challenges.
So connecting this to the bigger picture, what's the main takeaway for the near future?
I think the key question isn't if humanoid robots will become common anymore. The momentum seems too strong for that. The real questions are how quickly society adapts, and how we make sure they're deployed in ways that actually, benefit people, serve human flourishing, not just push technology for its own sake.
And timeline-wise, what might we see soon?
Based on the current trajectory, our analysis suggests we could very well see pilot programs starting up within the next year or two. Think warehouses, maybe logistics hubs, some hospital tasks, possibly construction sites. Initial targeted deployments proving the value.
Fascinating. What an incredible week it's been for robotics. It really feels like things are accelerating.
They really are.
We've covered the new brains, like Nvidia's Jetson Thor, making on-device AI supercomputing possible.
The edge computing shift.
The new minds, like large behavior models, changing fundamentally how robots learn skills.
From code to data.
The real-world tests, both the successes like Atlas handling disruption and the learning moments of the robot games.
Showing both progress and remaining challenges.
Yeah, it's clear we're at a really pivotal moment.
And underpinning it all, that growing financial investment and the ecosystem maturing, companies like Infineon and Nvidia working together to make mass production feasible, it all points to a future where these robots are, well, increasingly part of our lives.
Moving from just cool prototypes to potentially indispensable partners.
That seems to be the direction.
But the real revolution maybe isn't just the tech itself, it's how we choose to integrate it, right? Thoughtfully, making sure it genuinely enhances human life. That's definitely something to keep thinking about.
Absolutely. The societal implications are huge.
We always love hearing what you think. Whether you're watching on YouTube or listening on your favorite podcast app, please leave us a comment. Let us know your thoughts on the future of robotics, these humanoid breakthroughs. What excites you? What concerns you?
Yeah, we'd love to hear your perspectives.
Thank you so much for joining us on this journey into the future. From all of us here at Tomorrow Unveiled, we'll see you next time as we continue to unveil tomorrow today.